Hello everyone, my name is Harsh. In this video, I will be explaining and demonstrating my Arduino project where I have combined a push button and an ultrasonic sensor to control the two LEDs, a green and red. What makes this project interesting is that it uses interrupts, sensor readings, and a priority logic to decide which LED is on at any given time. Let's get started.
This is my hardware setup. For this project, I have used the following components: an Arduino Nano 33 IoT, a push button, an ultrasonic sensor, one green LED and one red LED, a few resistors with some jumper wires, and breadboard for the connection. The green LED is controlled by this push button. Each press toggles it on and off. The red LED is controlled by the ultrasonic sensor. When an object is detected within the distance 20 cm, it turns on. And most importantly, if both try to control simultaneously, the ultrasonic sensor has higher priority, so the red LED will take over. The push button is connected to pin D3 and I have used the internal pull-up resistor to keep wiring simple. The ultrasonic sensor uses pin 4 as the trigger and pin 5 for the echo. The green LED is connected to pin 9 and the red LED is connected to pin D8. The power and ground pins are shared for all components through the breadboard. This setup allows the Arduino to detect the push button pressing using an interrupt and measure distance using the sensor simultaneously.
Now, I am going to explain the main functionality of my code. But before moving further, let's have an eye on my code once. At the top, I defined the pins for the button, the ultrasonic sensor, and the two LEDs, green and red. I also created a few variables. The first one is button pressed is marked as volatile because it is changed inside an interrupt. The second one is green state, which keeps the track of whether the green LED should be on or off. And the third one is last red state and last green state. Store the previous LED states so the program doesn't keep repeating the same signals. This helps avoid flickering. In the setup function, I attached an interrupt to the button pin, so whenever the button is pressed, the interrupt quickly sets button press to true. There is no complex logic inside the interrupt, just a flag, which is the right way to do it. In the loop function, the first thing is to check if the button was pressed. If yes, if yes, we reset the flag and toggle the green state variable. This basically decides whether the green LED should be on or off, but the actual LED is updated later depending on the sensor reading. Next, the ultrasonic sensor is read every 100 milliseconds using millis. This is better than using delays or reading it continuously. It makes the program smoother and more responsive. The ultrasonic sensor sends a short pulse, then wait for the echo. From the time it takes, we calculate the distance. If the distance is less than 20 centimeter, it means an object is detected. In this case, the red LED turns on and at the same time, the green LED is turned off. No matter what the button state is, the given priority to the sensor. If no object is detected, the red LED turns off and the green LED is set according to the button state. So, if you press the button to turn it on earlier, it lights up. If not, it stays off. The serial monitor prints message only when the state changes, like when an LED turns on or off, so the output remains clean and easy to follow. So overall, the button controls the green LED, the sensor controls the red LED, and if both happen at once, the sensor has priority. Now, I am going to give you the live demonstration of this project. Here is my hardware setup. You can see this is our ultrasonic sensor, our green LED, and our red LED. Here is our push button. So, the first of all, our main step is to select the board and port, which are Arduino Nano 33 IoT and the port which is connected to our board. After that, we use this click button to compile our code, and when the compiling is done, we use this arrow button to upload our code. When the uploading is done, we are going to open the serial monitor. Here is my setup. When I press the button, the green LED turns on, and when I press the you can see the live readings on the serial monitor, which means the green LEDs toggle on and off when the button is being pressed. Now, I keep my green LED on. You can see here. Now I'm going to move my hand on an ultrasonic sensor at a distance of 20 centimeter and see what will happen. I place my hand at a distance of 20 centimeter and you can see when an object is at the distance of 20 centimeters, the red LED turns on and the green LED turns off. Earlier it is on. And you can see the live readings on the serial monitor. This is usually happens because of the priority has given to the ultrasonic sensor. Overall what it is, when I keep my hand at a distance of 20 centimeter on an ultrasonic sensor, the red LED turns on and the green LED changes into the opposite state, whether it is on or off. Which means that our project is working as expected. So, the conclusion is I used interrupts to detect button press instantly. I used non blocking ultrasonic checks to measure the distance smoothly and implemented priority logic to decide LED behavior when both inputs are active. This type of structure is actually very simple to what's used in embedded systems. Interrupts for the user input, time sensor polling, and a clear control hierarchy. This project can be extended further, for example, using the sensor to control motors, alarms, or more complex logic. Thanks for watching.